All right, mathletes, so how in the world do we graph these piecewise functions? Let's take a look. All right, so we see for this particular piecewise function, we have two parts, right? And so the first thing I want you to think about, right, when you're graphing these piecewise functions is this. I'm just gonna graph what does f of x equals -2, what does that look like? So let's just do a little sketch. This one, I'll graph it in blue. This one, I'll graph it in red here. So let's get my first little graph. So f of -2, that's just a horizontal line, right? Because that's our constant function. So -2 here, we got 1, 2. That's just going to be a straight line. Boom, it's going on forever in both directions, right? Soon we'll talk about the impact of these right here, our restrictions. But that's what that gives us. And if we graph this one, all right, let me just do another quick little sketch here. We know that's a line with a negative slope, so it's going to be from left to right going to be decreasing, right? So it's just a line, and it looks like this, all right? While the piecewise function, what we do is we see, okay, we have these two graphs here, but where do they exist? And this is where our domains, right, come into play. So here, this constant function exists only when x is greater than 0. So when x is greater than 0, what we're going to see is we're only going to see this part of our graph, the right hand side, because it's not defined for x being less than 0. So this, I'm going to pretend all this disappears, right? Because that part of the graph, boom, only exists when x is greater than 0. And this line here, for this red graph, -x, only exists when x is less than or equal to 0. So if I were to circle the part that I'm going to see, it's going to be everything to the left and including 0 right there. And what we're going to do is we're going to put those two graphs together to form one graph. But we're going to eliminate the parts that don't exist because of these restrictions here. All right, so let's go ahead and let's combine them so we could get a good picture, a good idea of what's going on. And there's so many ways you could do this, but again, it's helpful to understand your functions, your basic functions. This is a constant function, right? It's just a line, and a constant, right, horizontal line. And this one is a line with a slope of 1 and our x-intercept, our y-intercept of 0. All right, so when we graph these, let's go ahead and graph them. I'll do my red line first. We said it's going to look like this, and it's going to stop right here. And I'm making that dot right there just to show you that that point 0 is included, right? It is included, that 0.00. And for our other one, we said it starts at -2, 1, 2, but I'm going to have an open circle here, and that open circle is going to represent the fact that 0 is not included there, right? So as long as x is greater than 0, our height is going to be -2, and that's what that's telling us right there. So that's what our piecewise function looks like when we're graphing it. And again, this is great when you have that understanding and you don't need to plot points. But again, you could always plot points if you wanted. So if you wanted to, you could make yourself a little table, right? So I'm going to go ahead and plug in, say, negative values. So I'll choose -3, right? So if I choose -3, just like we discussed in our video of evaluating piecewise functions, I would have to figure out, where does this 3 go? Well, this -3 is in this region, so I plug it in here. So what I would do, f of -3 equals -3, and my answer would be 3. So when x is 1 to -3, my height would be 3 right here, and that would be my first height. And then I could plug in 0. I'll plug in 0 because it's nice. So when I plug in 0, I notice 0 lives here, right? Because 0 is less than or equal to 0. So that means I'm going to use this graph. And again, if you're having trouble with this piece, make sure you watch our video linked down below of how to evaluate piecewise function, because that's going to be huge, and that comes before graphing these. So again, make sure you watch that. And so we get 0. And there's our point right there. And of course, we're gonna connect those dots and we get our line. Well, let's plug in a number greater than 0. Let's plug in, and maybe I should have color coded this, it's all good. I'll plug in 2, right? And then I'll plug in 3. So when I plug in 2, 2's right here, and what this says is when x is greater than 0, right, which 2 is, I plug it into here, but there's no x value, which means this is a constant function, and it tells us any number that we plug in that's greater than 0, the output is always -2. So when I plug in this value of 2, 1, 2, my output is 2. Or sorry, -2. When I plug in the 3, 1, 2, 3, again, I'm going to get the same output because this is a constant function. So here I'm just trying to show you that if you're not very comfortable yet with graphing, right, lines or whatever it is, then you could always fall back and make a little table here, all right? But again, hopefully you've had enough practice where you don't need the table and you could see, you know, what's happening with these functions. All right, so there's our first example. Let's go ahead and dive into one that's a little bit more complicated. Follow me. All right, so now our functions are a little bit more complicated. Not really, but again, it's this idea that we have to wrap our heads around, okay? Probably the most important part of this problem is understanding that you have to like this video and subscribe, and don't forget to spread the word, right? We're trying to do great things for you here at Dr. Math Studios. All right, so we got our y-axis, we got our x-axis, and let's graph this mother sucker. All right, so x plus 1, well, we know this is a line, right? So this is a line, but where does our line exist, right? So what I like to do is, first I'll graph this entire thing here. All right, so let me graph this line. We know the x-intercept's at 1. Let me graph it in red here. My x-intercept's at 1, and my slope is 1. So I'm going to go up 1, over 1. And then I'm going to go ahead and let me use one of these nice little lines here. And I'm going to make this go on forever. Forever, ever, forever, ever. All right, so that's going to go on forever. Oh, my producer's telling me don't ever do that again. All right, so there's our line. And then we have x squared. So x squared, we know is a parabola, and this tells us where it exists, but we're going to ignore this for a time being, and I'll show you what to do. So this is just a parabola, and so if I were to plug in points, I don't need to plug in points. We should all know how this parabola should look. So it's going to have this general look, right? And so that's what they look like right on top of each other. But notice, these graphs don't exist everywhere. They tell us where they exist. So let's start with x plus 1. So this graph, this red graph here, only exists when x is less than -1. So x is less than -1. So here's -1 here. There's -1. And it's only going to exist to the left of this imaginary line. So this red line should not go anywhere to the right of this. So what I'm going to do is, let me take one of my pencils and let me pick a white out here. So let me white this out. So this graph does not exist. This red line does not exist anywhere over here. And what I did is I graphed it just to help me get the sense of what it would look like. And then what I do is I take away the piece where the side that it doesn't exist. Right, this is just one way of analyzing it, of looking at it. If you want, you could do what I did in that first example. Graph one by itself, graph the other by itself, and then overlap them. But when you overlap them, only write down where they exist. But right here, we're trying to paint a picture for you of what's actually happening. All right, let's look at this x squared. X squared, we know is this parabola, but where does that parabola exist? It tells you it only exists when x is greater than or equal to -1. So here's -1, and it only exists when x is greater. So what that means is when you're to the right, right? When you're everything to the right, you're gonna see it look like a parabola. But everything to the left, this doesn't exist here because everything to the left of this, look what it says. It's gonna look like this guy, a line. So let me white out all this stuff that's to the left because it does not exist here, all right? And our question is going to be, right, which one of these has the hole, all right? So because here, when I plug in, let's go ahead and plug in x equals -1 into our parabola, right? Is it allowed to actually, let me write this down for you. Am I actually allowed to plug in -1 into x squared? Well, that's the ugliest x squared I've seen. So am I allowed to plug in this -1 into this function? Well, yes, because look what it says. X can be equal to -1. So we can plug it in. So I'm going to plug in -1 right here. So I get 1. So right here at -1, 1, we're going to see a closed circle, right? The graph is defined right there. The graph is defined right there. But what if I were to plug in a -1 into this other piece here? So let's plug in there. Am I allowed to plug in f of -1 into this function? That's a question I want you to answer. Am I allowed to do this? And the answer would be no, because -1 does not exist here. But what I'm going to do is I'm just interested, if I did plug it in, what would be the height? Well, we would see the height would be 0. And right there, I would see a hole in my graph, because that point right there doesn't exist because -1 is not part of this domain, right? It's not included in here. So make sure that you put a circle there, and that's how you're gonna find where this line ends, is you actually plug this number into your function, all right? And I know that's a lot, and it's really gonna take some practice, right? I'm not gonna lie to you and be like, oh, everyone's gonna get like that. No, you need to practice this. So because of this, let's go ahead and do another example using everything that we just talked about. All right, so here we go, follow me. Right, so for this example, we got a lot going on. So let's use all these ideas and let's put them all together. All right, so here we go. So step 1, we're gonna go ahead and draw our little graph. Step 2, we're gonna make sure to hit that like button. Step 3, we're gonna hit that subscribe button. All right, so here we go. We know this is a constant, so everywhere x is less than 3, when x is less than 3, -3, excuse me, our height is going to be -1. So let's start there, right? So x, 1, 2, -3, right? Our height is going to be 1, 2, 3. But so I'm going to have an open circle here because I know I can never reach -3. And notice what the height is. The height is -1. So I don't know what the heck that was about. Let me erase that. We just said the height, right? The output is -1. So let's get that -1 in there. So there's our open circle. So as long as x is less than 3, boom, the height is always gonna be -1. So there's that one. This next one, let's go ahead and write this one in red here. And this graph, this part of the function, this piece is gonna be shown from -3 to 2. So from -3 all the way to x equals 2. X is 2. So 1, 2. And what does that look like? Well, it's going to look like a line. And we know as long as you have 2 points, you could connect those dots to make that line. So what I'm going to do, just to see where I start, where the start and finish is I'm going to plug in. So let's do a little chart here. I'm going to plug in my starting point, which is -3. And my ending point, I'm going to plug in 2. But just note, when I plug in 2, because it doesn't exist here, that's where I'm going to have my open circle. So write that down. That's key. So let's go ahead and let's plug in the -3 first. So f of -3, and again, I'm focused on graphing this piece right here. All right, so -3, I'm plugging it into -3 minus 1, which is -4. So we get -4. And this one, I know I'm not allowed to plug in that 2 because 2 is not included, But what this is gonna do is this is gonna help me see visually where that piece ends. So again, yes, I know 2 is actually not part of this graph, but the reason I'm plugging it in is because I'm gonna make an open circle, so that indicates that it's actually not part of this piece here, this x minus 1, but it gives me an idea of where that graph ends. All right, so let's go ahead and let's plug in f of 2, and I'm going to use the function x minus 1. So we're plugging in 2 minus 1, which is 1. And once again, yes, I know the graph is not included there at 2 comma 1. So 1, 2, my height is 1. So I'm going to put an open circle right there to make sure I tell my audience that that point is not actually included. And what was the first point? -3, 1, 2, 3, 4. And that point is part of our graph, right? So I went over -3 down 4 because, and this piece, look at that, -3 is included. So I made a solid circle right there. So let's go ahead and connect our dots, and we said we're gonna make this one red. So let's go ahead and do that. And let me move it up a little. That'll be good enough. All right, and again, make sure there's an open circle right there. So now, so far we've seen what our graph is looking like, and now our last piece. Let me make this last piece in blue here. All right, so f of x is 1. So when x is greater than 2, right? When x is greater than 2, my height is gonna be 1. So, and we're gonna do this in blue here. So when x is, let's actually plug in 2. I know 2's not in here, but just so I could see where to start. My height is 1. So right there, I'm gonna have an open circle because it's in this function, right? Let's change things up. Let's actually include. So right here, let's actually include 2, right? Because that's gonna be a better question for you. So we're gonna include 2. We're gonna change the problem up a little bit. So if I include 2, what that means is that I have a solid dot right there because that number is included. So when I plug in 2, my height is 1. And in fact, every single x value greater than 2 is gonna have a height of 1. So let's do 3. It's gonna have a height of 1. 4, it's gonna have a height of 1. So as long as you're to the right or equal to 2, your function, your graph, the height is gonna be 2 right there. All right, mathletes. So again, this is a big idea that people struggle with, and so you need that practice, and make sure you have the big idea before you just start diving in and handling these problems. All right, folks, so hopefully that was helpful. Make sure you smash that like button, subscribe, and we'll see you in the next video. Peace.